next communication, it's called Polyreactive Autoantibodies in the Physiopathology of Sjögren syndrome. It's presented by Rebeca Gutiérrez-Cózar from Societat de Barcelona.
Okay. Good evening, everyone. My name is Rebeca Gutiérrez. I'm doing the PhD at Pablo Engel's lab at University of Barcelona, and I'm going to present my thesis project called Polyreactive Autoantibodies in the Physiopathology of Sjögren syndrome. Okay. Sjögren syndrome, as all you may know, is a chronic autoimmune disease of unknown etiology, mainly characterized by lymphocytic infiltration in the exocrine glands and B-cell hyperreactivity. Sjögren syndrome is one of the most common systemic autoimmune diseases, and 90% of people affected are women. There are also extraglandular manifestations, and this B-cell hyperreactivity is translated, among other effects, on higher levels of autoantibodies such as anti-Rho, anti-La, etc., that are usually used as biomarkers in diagnosis. So in our lab, we analyzed the B-cell repertoire of a mouse model of Sjögren syndrome called NOT-H2H4 mouse model, using the females, of course, and we obtained a great amount of hybridomas, so we could analyze and characterize all these antibodies produced by these hybridomas. And the main conclusions of, well, I haven't said that, but as a control or non-autoimmune control of the mouse autoimmune mice, we used C57 black cyst mice as a non-autoimmune strain to compare the repertoire between the two strains. So the main conclusion of this study were that both autoreactivity and polyreactivity for both IgMs and IgGs are increased in the Sjögren syndrome mouse compared with the non-autoimmune mice. And importantly, most of the autoreactive antibodies found in these NOT-H2H4 Sjögren syndrome mice correspond to polyreactive antibodies. And on the other hand, we also observed that the frequency of IgGs that recognize Rho52 increases with the age of the NOT-H2H4 mice. And strikingly, we also find that all anti-Rho52 antibodies that were obtained from these mice were polyreactive. You can see here in the graph in dark blue. I don't know if the quality is really good, but in dark blue you can see that more than a half of the antibodies that are IgGs from these mice at 66 weeks old, were polyreactive. So then we wonder if this percentage of polyreactive antibodies is that high, maybe these antibodies are playing a role in the disease or not. So when we performed the repertoire analysis, we found that the predominant isotype for NOT-H2H4 mice, the autoimmune model, was IgG2B, while for the non-autoimmune strain, C57, the most predominant isotype was IgG3. So we decided to choose one polyreactive antibody from its isotype and its strain. So we choose for NOT-H2H4 an IgG2B polyreactive antibody called H2H4 7.50A. And from the non-autoimmune mice, we chose an IgG3 polyreactive antibody called B6-258IA antibody. So the main hypothesis of this project is that polyreactive autoantibodies that recognize Rho52 may be playing a key role in the disease development. So our objective was to study this pathogenic role of these polyreactive antibodies. So we wanted to determine if H2H4 7.50A and B6 2.58A polyreactive antibodies induce histopathological manifestations in an in vivo model that I'm going to explain in the next slide. and if these antibodies were also able to induce an increase of anti-dsDNA and anti-Rho52 autoantibodies in the sera of the mice with where we will perform the in vivo assay with. So for our in vivo assay to test the pathogenic role of these antibodies, we needed an acuter mouse model than the NOT8284 because the NOT8284 model is a good model and very used model for Sjögren syndrome, but we needed an acuter model to test the role of our antibodies in vivo. So we chose MRL mice that lack FAS. So they develop a lymphoproliferative syndrome, but with age. So we use them before the lymphoproliferative syndrome appears at 4 weeks old, and we infected them with a sublethal dose of cytomegalovirus for mouse, MCMV. So we waited 5 weeks, and at 9 weeks old, we made an endpoint evaluation in which we observed that an increase of anti-dsDNA and anti-Rho52 autoantibody levels in the mouse sera, and we also observed an increased number of infiltrates after MCMV infection. So we decided to use this mouse model. So our experimental design was the following. We took these mice at 4 weeks old. We injected with this sublethal dose of MCMV. We waited until day 19, when we started to treat with the antibodies, the polyreactive antibodies. There were 3 groups: H284 750A, B62 58A, and the control group that was injected with a saline solution. So an important point when working with polyreactive antibodies is that they have a shorter half-life than monospecific antibodies because this capacity of binding different structures. So they are eliminated before or more rapidly from the sera. So we needed to perform a half-life assay to see the time that we needed to how long we needed we could wait to inject the antibody between injections. So we obtained that we should inject our antibodies every 28 hours. So we did it for 2 weeks, and then we left 4 days and evaluated the immunopathological effects in salivary gland, external lacrimal glands, kidney, and liver. We also perform analysis to analyze or determine the autoantibody levels in sera, anti-double-strand DNA and anti-Rho52 autoantibodies, and we also analyze cell subpopulation by flow cytometry, both in spleen and bone marrow. So going to the results, the first result as we saw is that in the group treated with the H284 7.50A antibody, there was a higher number of infiltrates compared to the B6 group or the control group. And we also saw that there were a higher number of CD45 positive cells within the salivary glands of the third group, the H284 7.58 group. And here, I don't know what happened with the screen, but here is an image of the immunofluorescence assay where you could see the infiltration, and that the infiltration is higher in this third group than in the second group. So when we saw this higher infiltration of CD45 positive cells, we wanted to see, okay, which are the populations that are infiltrating the cells, the lymphocytic subpopulations that are infiltrating the cells in the 3 groups. So we stained for B cells, for T cells, CD3, CD4, CD8. I cannot show you yet the CD4 results because we haven't finished the samples and the analysis, but what I can show you is that although we didn't find any didn't find any significant difference for B cells, we have observed that there are more CD3 and more CD8 cells infiltrating the salivary glands of the mice treated with the antibody obtained from the autoimmune strain. And here, well, there are some representative images of each group, where CD8 is stained in red. So in this third image, you can see that is more red stained. So there are more CD8 cells than in the other two groups. And last but not least, when we analyzed by ELISA the sera of these mice to see the levels of the autoantibodies, we saw that there was an increase of a significant increase of the levels of anti-double-strand DNA and anti-Rho52 autoantibodies at the endpoint evaluation that was at day 35 compared to day 19 in the same group, or all the time points in the other groups. So with these results, we can conclude that H284 7.58 antibody, polyreactive antibody, induces salivary gland infiltration, and the group treated with this antibody showed a significant higher number of CD45 cells within the salivary gland, specifically for CD3 and CD8 cells. And that finally, that H284 7.58 induces significantly higher levels of anti-double-strand DNA and anti-Rho52 autoantibodies in MRL mouse infected with CMV. So we could say that IgG2 polyreactive antibodies against Rho52 induces pathogenic phenomena in genetically susceptible mice, indicating the possible role of these antibodies in the Sjögren syndrome pathogenesis. Yeah. And finally, I wanted to show you what is our next step and in which we are working now, that is producing a recombinant B6 to 58A antibody to change its isotype. So we want to see if we change the isotype from an IgG3 to an IgG2 isotype, will we obtain the same results of non-autoimmune effects on the mice, or it's only about the isotype of the antibodies because it's may fix complement or not? So this is the next step that we are working on. And finally, I wanted to thank you all for your attention, and my group, Pablo, Engel, and Angulo, Manu, Joan, and Javi. Thank you.
Rebeca, any questions? A really nice presentation. I have a question. Did you consider to sequence the BCR sequences of your clones?
The BCRs?
Yeah.
We have, in the repertoire analysis, we have analyzed a sequence of all the antibodies,
Yeah.
but not the BCR, so it would maybe...
Because I think this is really interesting, because our studies are more from the other side. We do a lot of repertoire analysis, but it's always difficult to know what's our sign for autoreactivity. So I think you have a perfect set to do it. It gives you a lot of information, because if you know the sequences, you could also look back in other mice to see whether you find these sequences at an earlier stage or... Another question I have, did you look at the glycosylation of these antibodies?
No. We haven't sequenced all the antibodies, the CDR3s, CDRs. We have make an analysis to see if they were antibodies, clonally related antibodies, and we obtained some interesting results, but I didn't have time enough to show. But not about the glycosylation. It would be an interesting point, yeah.
Okay.
Thank you.
Well, very nice, very interesting. Well, the anti-Rho52 are peculiar antibodies because Rho52 is also an immune function protein that it's modulating the immune response. And it's also modulating the intracellular intracellular bacteria or virus response. Then, and do you know, and usually it is supposed that part of the pathogenicity is mediated by the immunocomplexes deposition. Do you know in your model which is the supposed pathogenesis you are observing in the mice? And how do you know that this antibody is increasing this other antibody production in your model?
Could you repeat the last part of your question?
Yes, that how do you explain that the injection of your H2, H4, I don't know the number, in the mice are producing these new anti-DNA, anti-Rho52 antibodies?
Okay.
And how do you measure the mono and the polyspecificity of the antibodies?
Okay, the last is easier, so I start for the last part. We determine if an antibody is polyreactive using ELISA panel of antigens that include different structures, the double-strand DNA, histone 1, LPS, actin, insulin. So we have a panel with a lot of diversity, structural diversity. So we determine that an antibody is polyreactive. It binds 3 or more antigens of our panel, and this is used by other groups. And about the pathogenic role of these antibodies and the way they are pathogenic, as you have said, Rho52 has an important role also in interferon type 1 signaling and so on. So, and there is also been described that Rho52 is more expressed in salivary glands of patients with Sjögren syndrome. So I think that if there is a higher expression of, maybe we haven't studied that, but in these mice, there is an overexpression of Rho52. Maybe our antibodies are recognizing, among other antigens, Rho52 in these salivary glands, and as they fixed complement. And this is what we want to see in the next step I mentioned. Maybe they initiate an inflammatory response there that may cause the infiltration of more lymphocytes, such as CD8 cells that I have shown before. So maybe they help the inflammatory response to be increased.
Are supposed to be produced by different B cells that may be T-independent and T-dependent responses.
Mm-hmm. Thank you.
Thank you, Rebecca.